Assalamualaikum warahmatullahi wabarakatuh. At first, let me introduce myself. My name is Gilar Pandu Ananto. I'm a researcher in Wahid Hasim University. In this occasion, on virtual event TIDAR International Conference 2022, I'm gonna present about my research with the title of Development of Brain-Controlled Robotic Hand Using Non-Invasive Wearable EEG Sensor. Introduction. Electroencephalogram, or EEG. Electroencephalogram has the capability to detect signal from our body, just like an EMG. So, both of electroencephalogram or EMG, electromyogram, both is a biosensor that can detect biosignal from our body. But the difference between electroencephalogram and the electromyogram has the capability to detect muscle contraction, but the electroencephalogram has the capability to detect activity in our brain. EEG has the capability to detect waves that emitted from our brain. There are several waves that can detected using EEG sensor. There are delta wave, there are theta wave, alpha wave, beta wave, and gamma wave. As you can see on the screen, each wave has the relation with the mental state and a condition. Based on the previous research of EEG signal, it was known that the pattern of each wave could be combined to identify specific activity. Later, in the case of robotic hand, the combined pattern can be used to initiate various mode or movements so the robotic hand could mimic more activity from human hand. Recently, the robotic hand research was growing significantly, but most of the robotic hand utilize the electromyogram or EMG sensor. Due to the potential of EEG sensor, the research will focus on developing robotic hand using EEG sensor as the movement trigger. Method. The EEG that was used in this research was a EEG headset with a single channel electrode. This EEG headset has the capability to detect 5 types of the brain wave. It also has the capability to identify the brain state by comparing the alpha and the beta wave. The compared value has the range between 0 to 100. On the scale of value between 40 to 60 indicate the natural state of our brain, 60 to 80 indicate the focus state, and the 80 to 100 indicate the high focus state. In this research, the focus value will be captured and then used to trigger the robotic hand. But since the focus value could be vary in each person, measurement will be conducted to get a minimum focus value that will be used to trigger the robotic hand. An Arduino Uno was used as a microcontroller in a robotic hand that was used in this research. And since the EEG headset only came with a Bluetooth connection, a Bluetooth module AC05 also used in this research. In order to create the prototype of the robotic hand, a palm model that used in this research was the FlexiHand. FlexiHand is an open source model created by Steve Wood that you can access in Thinking First. Both palm and the finger component will be manufactured using a polylactic acid or PLA. The joints will be manufactured using a thermal polyurethane or TPU. Nylon string also attached on each finger, which will be used to pull the finger. Since the FlexiHand only came with a palm model, the arm components should be designed in order to put the moving mechanism of the robotic hand. And here is the arm of the robotic hand. The arm of the robotic hand has three main components. The first component is a rack and pinion gear. This rack and pinion gear were made of acrylic and used as the moving mechanism. This mechanism will turn the rotation of the servomotor into a translation movement. The tip of the rack will be coupled to the string in each finger. The second component is the upper arms, made of PLA and used as the rack track. The rack's maximum displacement low was 35 mm. Upper arm was paired into two bodies for easier printing, and the third component is the lower arms. The lower arm made of PLA and used as the bracket of both palm and the servo. The lower arm was paired into four bodies for easier printing. And here is the robotic hand that already manufactured. Result and discussion. Brainwave measurement was conducted on 12 study participants. Each study participant was instructed to think the word of Genggam to initiate the focus state. After a few seconds, the study participant was instructed to relax their brain while took a deep inhale and exhale in order to lower the focus value. Later, the measurement value will be used to set the threshold. And this is the measurement data of each study participant. Based on the measurement, it's known that the lowest maximum focus value was in the range between 70 to 80. Based on this information, the threshold was set at 70 due to the lowest point of all the participants. The threshold line with the red color can be seen on the figure above. If the value passed the line, the robotic hand will perform flexion, and if the value was below the line, the robotic hand will back to the normal state. Here is the video of the EEG-based robotic hand. As you can see on the video before, the brainwave signal, which is represented as the focus value, was able to trigger the robotic hand to perform flexion movement. However, the signal value was very sensitive to the environment and the condition of the user. This might be solved by adding potentiometer in order to modify the signal in real time so it can be adjusted to specific condition, but this claim needs further research. Conclusion: the robotic hand movement is able to be triggered using EEG sensor. When the value of focus reaches 70, which is already set up as the threshold, the servo starts to rotate and pull the finger of the robotic hand into a flexion movement. Later, when the focus value decreases below the threshold, the servo motor starts to rotate back so the finger of the robotic hand could move back to its default position. The current research is still limited to only one movement. For further research, there are several topics. First is the moving mechanism that will be redesigned so each finger can move independently. Second is the research to combine the brainwave in order to find another unique pattern that can use as the movement trigger, especially when the mechanism already supports the multiple movement. And the third is to build a real-time adjustment system which can modify the threshold depending on the specific situation. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.